Welcome back to this last video of the review of Calculus 1. This one devoted to analytic geometry. Well, that will deal mostly with properties of the line. So a line passing through 2 points being x1 and y1 and x2, y2. This line has a slope, which is actually well known to be delta y over delta x. We actually call this A or M, and we define it as exactly y2 minus y1 over x2 minus x1. The y-intercept of the line is a point B, where the line crosses the y-axis, so 0, B. While the x-intercept, we could call it C, it's a point where the line crosses the x-axis, so C, 0. Well-known equation of the line, y is equal to ax plus b. We saw that in the previous video where a is the slope and b is the y-intercept. So what can we actually do with this? Well, we can try to work out like this example. We are going to be looking for the equation of a line passing through a certain point minus 3, 5 and having the same x-intercept as the line 4x plus 3y minus 8. So if you want to find the slope of that line, you need 2 points. So we're going to have to extract another point from the line that has the same x-intercept as our line. So to find the x-intercept, we are simply going to replace y by 0 into the line that is over here. So we're going to get 4x plus 3y, so 3 times 0. Minus 8, and that's just 4x is equal to 8, and that's x is equal to 2, and that tells us that the x-intercept of this line is 2, 0. So now the line that we are interested in has the following property. It actually goes through the point negative 3, 5 as well as through the point 2, 0. So from this, it should not be too difficult to get the slope. So let's calculate the delta y over the delta x. 5 minus 0, minus 3, minus 2. That's 5 over minus 5, and that's minus 1. Meaning what? Meaning that y equals ax plus b, which is the general equation of a line, now can be written as y is equal to minus 1x plus b. And all we need is to find the y-intercept, so that's easy. You put in one of the 2 points, say the second one 2, 0. So we're going to put 2, 0 in the line, and we're going to get 0 is equal to minus 2 plus b, meaning that b is 2. So finally, the equation of the line is y is equal to minus x plus 2. Easy enough, easy enough. Let's talk about a couple of properties of lines. So 2 lines, L1 and L2 are parallel if their slopes are the same. So if A1 is A2, the lines are perpendicular if the slopes are in negative reciprocal to one another. So A1 is minus 1 over A2. Let us use this newly, well, not so newly, acquired knowledge in solving the following example. Looking for the equation of a line that is perpendicular to 6y plus 3x equals 1 and having the same y-intercept as the line 4y plus 5x minus 18 equal to 2. So why don't we first try to extract the slope. So from the line 6y plus 3x equals to 1, we could actually see that 6y is minus 3x plus 1. That is, y is minus 3 over 6x plus 1 over 6. This line has a slope of minus 3 over 6, which is minus a half. So the line that is perpendicular will have a slope let's call this A1, let's call this A2, of minus 1 over A1. So that's minus 1 over minus a half. That is just 2. Now we have the slope of the line we are looking for. It also seemed to have the same y-intercept as 4y plus 5x minus 18 equals 2. So how do I get the y-intercept from the second line? I simply replace x by 0. So if I replace x by 0 here, I'll get 4y plus 5 times 0 minus 18 is equal to 2. That is to say, 4y is 20, so y is 5. So that is the y-intercept. That is my value of b for the line. So we're done. Y is equal to ax plus b becomes y is equal to 2x plus 5. That's it. C'est tout. Points of intersection, also something that we will need to be able to find later on in the course. So the best way probably is the comparison method. It's by far not the only way. We've heard of addition method, we've heard of substitution method. Whatever you are comfortable with, you can use. In this video, the comparison method will be the #1 tool, since it's probably pretty easy to use. So how does it work? You isolate the y in the first equation, you do the same in the second, and you equate them to each other. In this example here, the first line has to read y is equal to 2x plus 7, simply because I brought the negative 2x on the other side. In this one here, I am going to have to fiddle around a little bit. 6x plus 4 is equal to 2y. Dividing by 2, I get 3x plus 2 is equal to y. So that's kind of line #1, and that is line #2. So by making the y's equal to each other, I end up solving 2x plus 7 is equal to 3x plus 2. What is that equal to? 7 minus 2 is equal to 3x minus 2x. So 5 is equal to x. We have the x point of intersection. How shall we find the y point? We will replace in either equation. So say the second one, y is equal to 3x plus 2. If x is 5, we get 15 plus 2, we get 17. So the point of intersection of these two lines exists, and it is simply given by 5, 17. That is the answer to this problem. And on to bring everything together into one problem. So the summative example here, we have a line L1, 2x minus 3y plus 6 is equal to 0. And we have a parabola, y is equal to minus x squared plus 3x plus 24. We would like to find the equation of the line parallel to L1 with the same x-intercept as the line 5x minus 3y plus 10 equal to 0. Searching first for the slope. Since the two lines are parallel, so we need to extract the slope from L1. L1 is what? 2x plus 6 is equal to 3y. That is to say, y is 2/3 x, and 6 divided by 3 is 2. It appears that this line has a slope equal to 2/3. And because the lines are parallel, then this is also the slope of our line. So now about the x-intercept. Well, the x-intercept, as we all know, is found by replacing y by 0. So 5x minus 3 times 0 plus 10, that is 0. So 5x plus 10 is equal to 0. That's minus 2. And we know what that means. It means that the point minus 2, 0 is the actual x-intercept of the second line. So we now have a point on the line that we are trying to find. So we have a slope and we have a point. Shouldn't be hard to finish it up. So y is equal to ax plus b becomes y is equal to 2/3 x plus b, since the slope is 2/3. And now we're going to replace y by 0, and we're going to replace x by minus 2. And what are we going to find? We're going to find that b is actually 4/3. So combining all this together, we have that y is equal to 2/3 x plus 4/3. That is the equation of the line that satisfies all of these conditions. And on to find now the point of intersection between the line L1, which I will rewrite as 2x plus 6 is equal to 3y, which of course is the same as y is equal to 2/3 x plus 2. That and the parabola, which we have as minus x squared plus 3x. So y is equal to minus x squared plus 3x plus 24. So call that equation 1, call that equation 2. We're going to make equation 1 equal to equation 2. And we are going to find that 2/3 x plus 2 is minus x squared plus 3x plus 24. I'm going to bring everything that's on the right side to the left side so that I have something that is equal to 0. So I'm going to get minus x squared becomes positive x squared. 2/3 x minus 3x, that's going to become minus 7/3 x. And 2 minus 24, that's going to become minus 22. Now, I'm not a big fan of factoring something with fractions, and even less doing the quadratic equation when I have fractions. So I am going to multiply both sides by 3 so that I get rid of all fractions, and the equivalent equation is 3x squared minus 7x minus 66 equal to 0. Factoring of this can be done with a little bit of patience. Here's 3x, here's x. 66 is not that many things actually, and 11 times 6 is most likely going to be the winning ticket. I'm going to put a plus here and a minus there, and that will do the job, so that I actually have here 3x plus 11 equal to 0, and x minus 6 is equal to 0. So I get here that x is minus 11 over 3, and here I have x is equal to 6. In order for us to complete this problem, we need to replace these x's either into the line or into the parabola. So this is really an exercise that is going to be left to you. If you replace minus 11 over 3 into either equation, you will find minus 4 over 9. And if you replace 6, you will find y is equal to 6. So these are my 2 points of intersection for this problem. And this complete